Hi, let's talk about trig functions. So here we have to graph y equals 3 times the sine of 2 times x minus pi over 4 plus 4. So we know the universality of transformations, right? We have something out here, and this is, oops, sorry, that should be a D. And this is going to affect how tall or skinny something is, right? It's the stretch. And then here, this is going to affect the period because trig functions have periods and other types of functions don't. This is possibly new to you. And then in here, we have horizontal shifts. And then out here, we have our vertical shift. This guy in a trig function is called the amplitude, but it kind of might want to let me right there, sorry. But it kind of has the same idea as, an A outside of a parabola or something like that. So that's our general form. And let's kind of use that to put this all together here. So let's think about a regular sine curve. Regular old sine curve. Here he is. He goes from here to here. He completes one cycle at 2 pi. His max is at 1. His min is at -1. And he starts at the origin. Cool. So there are these points along the sine curve, right? This is where he starts, okay? This is called the mid. This is going to be his max. This is going to be return to the mid. This is going to be the min, return to the mid, okay? So that's the general progression for where the points are on a sine curve. Another name for the midline is the principal axis. That's what they call it in IB. But you can just remember that it's always the midline or the line straight through the middle. Cool. So in terms of this regular old sine curve, let's think about this new transformed one, okay? So let's examine the transformations that have occurred. Here I have an amplitude of 3. So that means instead of my regular old sine curve with its midline at y equals 0, it's now going to stretch. So it's 3 units up and 3 units down from the midline, okay? While we're considering the amplitude, let's also consider the vertical shift. If we're considering the amplitude and the vertical shift together, we now know that we take this midline from 0 and we shift it up to 4. Okay, so now our midline is located at 4. And then we know that the amplitude, we can call this the midline or the principal axis, however fancy you are feeling today, you choose. And then up from the midline, we have a maximum at 7 because that's 3 units up from the midline. And then we're going to have a minimum 3 units down from the midline, and that's going to occur at 1. Think about these like your train tracks, okay? The trig function is going to be sandwiched in between the max and the min, and it's going to be passing through the midline periodically. Which actually brings me to my next point. Let's talk about the period. So this B here is probably unfamiliar to you, but he affects the period of the curve, right? So here, this is starting at 0 and ending here at 2 pi in this untransformed sine curve. So his period is the time that it takes to complete one full cycle, okay? The relationship between B and the period is as follows. So in a trig function, the period is equal to 2 pi over B. And the B is coming right from the equation. The B is 2. So I'm going to substitute that in and find out what the period is going to be. 2 pi divided by 2 is leaving me with just a plain old pi. So that means this graph is going to complete one full cycle in pi units. So let me go ahead and label my axes so that way I can accommodate. Let's do 2 full cycles so we can really see what this guy looks like, okay? So label your axes. And then take note of the horizontal shift at this point, right? If I'm shifting this guy to the right pi over 4 units, I'm probably going to want to count by pi over 4 so I can really see what's going on. So go ahead and further split this. Okay, cool. So now I've got my axes completed. Awesome. So if you notice, the sine curve is usually starting right here at the origin. So this would be if it were business as usual. It would be starting right there. However, this has a horizontal shift of pi over 4 units. So I am shifting this whole graph over from here to here, pi over 4 units over, pi over 4 units over, pi over 4 units, pi over 4 units over. Okay? So instead of completing one full circle in pi radians, it's going to be completing one full circle in pi radians, but it's starting at pi over 4 and it's ending at 5 pi over 4. So let's go ahead and put those little parameters up here for us, okay? So it's starting, shifted over at pi over 4, and then we know that the general progression of the points is such that we start at the midline, we go up to the max, we go back down to the midline, then we head down to the minimum, then we head back up to the midline. And if you'll notice, we've completed one full cycle or one period between pi over 4 and 5 pi over 4. And our period is just a pi. So let's repeat it, right? We are going to start at 5 pi over 4, come up to the maximum, come back down to the midline, and then here we go. He's going to come down to the minimum, except I didn't include this last little piece here. So 2 pi over, that'll be 8 pi over 9 pi over 4. There we go. Now he's completed 2 full cycles. He looks real good. Okay. And then, of course, we put little arrows on the end and we label him. And we're all done. Voila. Of course, when you're graphing these, you want it to be more of like a smooth curve, but you know. How long have you been in my class for? Ain't nothing's perfect, right? Okay. Enjoy the rest of your homework.